Are we live? Let's go. We're live. And hello, everybody. This is Next Stream. We are working on the server. Um, Today we are working on the server implementation. Today we are working on lobby. I think I have extrapolated this server to a new file and lobby. So um, I think it would be nice to try to, because we can get a couple clients right now. This is something I tested a second ago. Okay, I'll show you it. We run a server here. We run a client here. It will connect. Then we can go here. We can run a client, and we'll see that there is next user. It's 15. This is 1537 153866, and then we can do like next client, and another client is connected. We can ping from this client. We can ping from this client. We can ping from this client. Everything works. So this is really good. This is really, really solid. Now, what I want to do today is create a system that will let us do the following. Let's define a const expression, assign the integer 8. Um, let's call it a limit number, limit max players in lobby. Let's say it's free actually. Let's say it's free for now. We should actually rename those to be compliant with standard. What I want to do is create a basic mechanism for detecting how many players are there, and we'll do this by um, using a condition variable that will be notified every time it runs. And when this condition variable is, say, free, this server will send a message to everybody like, "Oh, all players met," and then it will disconnect. That's what we want to achieve today. This is a small step, but it will allow us to detect when the players are kind of ready to start the game, and I think that it's a good step for today. So for that, we'll need a mutex. Mutex, actually, defined here. Well, we can start with class like lobby. Let's say you have a private. For now, for simplicity, we'll assume that there will be only a single lobby, and then we'll try to extrapolate from that. Let's not do the whole system in one day. So there's another variable. There's mutex, and this mutex will be a mutex on. Actually, yeah, and there will be some kind of condition variable cb. Let's call it now like that, and let's not worry. Let's not worry about it. Yeah. Okay. Now lobby needs to store somehow in the store WebSockets, right? In the store WebSockets, well, actually WebSockets and probably clients. Um, so let's for now make a structure called like lobby entry, lobby mm, participant player participant, and this participant will be composed of it will be composed of a WebSocket and probably a connection state, a pointer to a connection state, a shared pointer to a connection state. I guess that's so a WebSocket and a pointer to a connection state. Um, yeah, that's what it's going to be composed of. Hello to somebody who has joined right now. Um, who joined, but hello to the conference. Nice to have you. But yeah, going back, this participant will have standard shared pointer to connection state. And it also will have kind of reference. Well, I don't know if it's a weak pointer, but it might as well be a weak pointer. Um, and well, I want it here though. Like, please stop indenting it. What a stubborn piece of formatting software. Well, and now every time a new connection is made, we want to call this. We want to kind of we want to call the vector of participants. We want to call basically um, pushback on this vector of participants, or rather probably an place vector. I don't know which one will like, better in this situation. We'll think about this. But for that, we need kind of like an observation mechanism for server. So let's create a public class server observer. Server observer. That's a funny class. What? Oh yeah. And the server observer will be a class that will have a virtual method on new connection established. And this on new connection established will also take in shared pointer and this WebSocket. And and it will be what's wrong? Oh, there is a return function. Virtual void only connection established. Okay. And now this server it will have oh my god. Actually it's called just observer. We'll have a vector of observers here. Yeah. And now what we're going to be able to do is that we'll be able to subscribe to these observers, and mm, this is public. And now every time a new connection is established here, oh well, where is it exactly established? Give me a second. Open here. Every time a new connection is established for server, let's say if server Now we will do for should those be pointers to observers or observers? Give me a second. I think those should be pointers. Yeah. For every pointer to observer in observers, what's wrong here? Use non-static data member. Use of non-static data member server from nested type. Can't we do that? That's not good. I thought we can do that. I was like kind of sure we can do that. If we can, that's a bummer. Still not. Use of non-static member server from nested type. Well, okay. I mean, there is a fix for that. On the new mm, connection established. And now we can just create this method for a server to be a public method. Over here. It will take this, taking this parameter. It will go over for server observe. It will go over the observers, and it will call for each observer. It will call on new connection established. With connection state and WebSocket. Okay, what's going on? Oh, I see. It will call it. And now here we can call it with the connection and WebSocket. And now we'll get a pretty reliable method to track once somebody is connected to the server. So now we can just, what we can do right now is pretty simple. We can just declare lobby to be a public server observer. And now we can implement this method hmm, for the lobby. And it's actually a pattern that I learned at Google. It's super useful. Like I've used it actually so many times at this point. So we'll think about it in a second. So don't worry. But now we kind of need to deal with the construction, right? Because if you want to construct properly, we should be this should actually take in the server uh, a reference to a server because server can be null, right? So we are taking the reference to server, and we will have a private variable server here that will actually be a reference, right? There is a difference between a reference and between a reference and a pointer, and this main difference is that the reference it can be null, right? So when you're writing code and you want your member to never be to always be basically if you want to remember to be permanently present, permanently assigned, you make it a reference to the pointer. And I think it makes sense. Okay, what's going on here? Oh yeah, it should be explicit, yeah, because we are passing in only one thing. And now also in the constructor, we should call server add observer. So we should create this method here. and it's a count because we are going to modify it. And then we are calling observer pushback observer. What's wrong? What's wrong? Oh, because it's not because it's type of const pointers. Yeah, that makes sense. And then we also have void remove observer. Observers. Actually, we call it like that. It's defined. Um, observer. Oh, there's like remove if, right? There's this called equals remove if. Um, erase vector erase the specified element, but it's we must have found it first. So we can also probably use this. Yeah, just standard remove. Um, observers begin observers and observer here, and this should remove the observer. What's your problem? What kind of return value it has? For iterator. Yeah, I didn't care about it. Okay, removes past the end iterator for the range. What? Past the end iterator for the new range of values. Hmm. Yeah, I don't think we care about this value here. Oh yeah, because we are string. Yeah, so then those are just normal pointers because we are probably this might be modifying code, so we don't really want to touch it. So those aren't most pointers. And now we are going to here and we are doing server add observer this, and upon destruction we should remove ourselves from this server remove observer this. Now this is like a really standard observer pattern, but it's so goddamn useful. Like I've used it like so many times at this point. Hmm. So yeah, what was I thinking? Yeah. Well, I don't know if this is actually we'll use it. Let's just build it out slowly. Yeah. So it hesitant. Um, okay, so when new connection is established, we should add it to the server, not to the participants vector. Okay, so participants in place back. Now we can just pass connection state in the WebSocket here. Okay, maybe let's make it a little more straightforward for now. Set on callback. Let's make it so that every time somebody joins, we'll just print out their name on the screen. And so for auto participants in participants, we'll do participants WebSocket. And now what we should do is just for each of the sockets, we should just send data, send a string. Um, okay, so what kind of string? So we should do. How do we get access to the name? Let's check this out here. Connection state. Okay, let's just send new player join. Okay, let's just do new player joined. Mm, and let's now create a lobby that will take in a server as a parameter. And let's build it. Mm, let's build it. I hope it builds. Yeah, it builds. Okay, now let's create a server, and then let's run a client. Okay, as you can see, we have the output nuclear joint. Let's create another client. Yeah, and there's another player, and another socket, and next player. This is absolutely in perfection. This is really good, I would say. This is some progress. Okay, and then let's just. Okay, perfect. Mm, now, okay, what do we need to do next? Um, we have successfully created the lobby. What to do now? Mm, now that we have the lobby, we can take how many players have joined. We should be able to establish that okay, this amount of players joined, Let's do like um, I'm really thinking about this. This is really tough because I'm not really sure which is the correct direction. We should also do a call for a collection close, I suppose, so we can clean out the participants, which I guess would be probably good. Um, because I don't know what happens when, yeah, so we should probably do that. Mm, sure. Now we should look for clothes here. And then now we also must override this method, right? Void virtual void on action close override. Hmm. Now what we'll do, we will probably do something like that. Hmm. Now, how is the shared point? How is shared point compared? I don't know. Anything sure. Okay, so we're comparing the underlying counter. So that's good, I guess. Mm, what's the problem? What seems to be the problem here? Oh, I see what seems to be the problem. So what we'll do is we'll create a lambda that take actually, yeah, this is it, unfortunately. I will take in two participants and participant B. You can do it with autos, I guess, but maybe you should do autos here. What's your problem? Invalid operator binary global participant oh, and what cost? What? Invalid price binary expression and count. I understand this one. Hmm. Okay, so it's binary. Let's remove if now is the problem. I'm retarded, I'm sorry. What is that, man? Forward first, forward last, unary predicates. Okay, man. Okay, so it works. It's pretty cool. Okay, so apologize. I didn't use code correctly. Okay, maybe tomorrow we'll get more people or something. I'll do ask you to know about it. I'll just call in private.